Hey, it's Eric from VFX Tools, and we're going to do a tutorial for this new thing called Spark Flint, which is basically copycat in Nuke, but you don't need Nuke or copycat. You can run this in After Effects Flame. You can also run it in Nuke, so you don't need additional expensive Nuke licenses. Here is a hold on. Here's a website talking to you about what that is. So you can see you can train your own AI tool or model one shot at a time. It teaches a small AI model to do one repetitive task on your footage, like paint out, beauty, cleanup, or roto, by showing before and after frames and training it on them. This site kind of explains all the jargon in a friendly way and what settings you can use. What we're going to do is I'm just going to show you how to submit a job. And then here's kind of a cool one that shows the differences between this and copycat. So here we go. What we're going to do is get rid of these reflections on this lady's glasses. So whenever you train one of these models, the first thing you want to do is crop down and stabilize the footage. You want to crop down to like the smallest amount you can of a square thing. So I've got this 512 by 512 box, and what I did was I nano bananaed and comped in these fixes. So if I turn all my fixes on, you can see here we've got a fixed frame with no reflections, boop, boop, boop. Is it perfect? No, I'm making a tutorial and trying to like make this go quickly. So it's pretty good though. I think a lot of clients would be happy with that. All right, so what you do is you export the before, which we call the source, and the after, which we call the destination. They go into a folder labeled source and dist. I think you can also call it input output. The Flint website says what's supported. So in here we have the files, all those frames that we fixed, and all the frames as they were originally. When you're making these frames, you want to kind of try to find which ones are the most different from each other. So here she's turned her head, so that's pretty different from this. Here she's blinking, that's kind of different. Here I don't remember why I chose that one. Maybe the reflection was different. Here again, she's blinking and turning her head. Her eyes are kind of like half open. And then on this one is very similar to this. And maybe I didn't need it. I'm not sure. When you do fixes that are really, really similar, you got to be careful. They have to match like perfectly, or you're going to confuse the model because it's like, is it this fix or that fix? And you'll get flickering and weirdness. All right. So now we're on the Flint dashboard. I'm going to, and that guide is over here if you need it. And what I'm going to do is make a new job. And the training mode, you can do new, resume, or you can fine tune a model. We can learn what that means later, but not right now. We would call this like, I already have one called glasses, so I'll call it glasses 2. The training data, you can do a source, input, source, destination, output, target, and it will find them. The other thing that you can do is, got to click upload. So there they go. You can also add validation. So validation would be frames, additional frames that aren't in the training data. So like here's one. And what you would see there is you'd see the model running on these validation frames and get to see, is this actually working on frames that aren't in the data set? I'm being lazy, so I'm not doing that right now. Okay, so then we're going to pick our preset. It explains to you why you would want to pick one over the other. And this one, we're going to do, it can either be a beauty or a paint cleanup. I think I'm going to do this beauty one. We can leave this at 512. That's the size of the images. If you set the resolution lower, it splits those images up into chunks and trains on those chunks. And because we are doing 512, and that's the size of my images, I actually don't need overlap factor. Overlap is kind of like a blending, and we'll see how to use that later. And then I'm going to go here and go to mask and skip empty, these settings. So mask weight, this is something that Copycat doesn't do. It's basically saying anywhere that we find this white area, the diff between before and after, is where we want to concentrate our training. I actually don't know what is the best number to use for that right now. But what I do know is you don't want it to look like this, where the gamma is really pumped, because it's going to train on these areas that we don't care about. You want it to be black, but you don't want to crush it down too far. So just where it gets there, 0.75. And then this is kind of cool. I'll show you in case you have something like this, where if you show the diff, hold on. We're going to set this to 256 right now so you can actually see. These are the little 256 chunks, and you can see that if I'm splitting the image up, some of these don't have training data in them at all. So we would set a threshold for what's like included and not in our fixes. And here you can see that this one gets left out because there's nothing being changed in that. The rest all have something being changed. As you can see, I don't know, man. Why did I do this and slow down the tutorial when we don't actually need it? That was stupid. All right, so now we're going to use this instant node, and we're going to click review pairs, which you have to do before you start training. That is because oftentimes when you're doing this, you'll make a rendering mistake, and imagine it was like this lady's face is a before, and then after it shifted down a bunch because you made a mistake. Then it would train on that, and you'd come back to your model and be really upset because you trained on a bad frame. I just did that recently. I had one frame that was like overly blurred because I forgot my masks, and it screwed up the whole training. Really great. Felt great about that. So I had to do it over. This proves that our data is good to go. We go to approve pairs, and then you click start training. I have one already going, which I'm going to show you. This one has been training for 3,720 steps. Finding out what steps and epochs are, you're going to use this help guide. That should help, and you can look up tutorials about Copycat because it's pretty similar. This shows that our model is improving. Our little line here shows that it's improving. If we go to the last 5 of these, we can show that it's on a downward trend, which is what we want. We want this loss curve to flatten out, and then when it gets too flat, then it's too much. This down here, this analysis will tell you how it's going and whether you should keep going or not. We are 7.5 epochs in here. It's going to cost us $2.84 per 10 epochs. Epochs, up to you. And here is the console output from the cloud computer that we're using, and we can see if anything's gone awry here. I just exported one of these, but we've done a little bit more work since then, so let's... Oh, wait, before we do that, here is this. These are our before images over here. These are our after images that we gave it, and here is what it looks like when we are inferencing on that. Inferencing is apply the model to the source and see if it works. You can also see the diff between those images. Yes, we worked on the eyeglasses, and here is the gamma that it's using to say, train more on this, on the white than the black. So this model looks like it is working pretty well. So what we're going to do is download the model. So I'm using it in After Effects. We're going to export. That's going to take a couple minutes. I'll be right back. All right, that was probably a minute. The file came up to download. It downloaded. Great. So we're going to go back to After Effects, and we're going to go come out here. You want to apply this on a cropped version of the footage. Because if you apply it on a bigger version of the footage, you're running this inference on too much, and it's going to slow it down. I am going to apply this After Effects plugin that lets you use the model in After Effects, which is cool. You can also use this in Flame. There's like an ML inference node, and then there's a download for Copycat where you convert a PyTorch model to copycat to a .cat file. There's tutorials for that. I don't have that. I don't use Nuke. All right, we're going to load the model. We're going to load it here, and then we can see how well it worked. So here we go. That's pretty cool. That's pretty good. We haven't trained it for that long, right? So I can still see some reflections kind of passing by her eye. But boy, it's a heck of a lot better, right? And you can see where my paint fixes weren't perfect, her eye shape kind of changes. You could obviously refine that. I'm just trying to get a data set out for a tutorial. I think if we kept on training this, we'd be looking pretty good. So back here, we can see the model's still improving. We're only 7.7 in. And I have found that in the beauty fixes I've been doing, that it takes like 10,000 steps to even prove that it's really going to work. We're so early on here. I could post an update later to make sure that this really fully worked. But that's the overall idea. So we would take this to like, I don't know, like 30 epochs. And at 283, so let's call that $3, you could be out of here at $9 with a model that works for this. I just did this show where we had to fix this person's hands. She was wearing these gloves with her fingers sticking out, and we had to make it look like she wasn't wearing these gloves, right? And so there were 60,000 frames to do. You can't paint out 60,000 frames of someone moving their hands all over the place. It's basically impossible. So what we did was we painted out about 500 frames from all the different shots and all the different situations and ways the hands were arranged. And then we trained a model for hours and hours and hours. And that's how we fixed the hands. Because when you then run that model over all these different shots, like, you can't believe how efficient the fixes become. You know, on a single shot, sometimes this is kind of the only way out. Glasses reflections like this are a good way to fix that. But maybe you could do it the old way too, you know, the traditional way. But with something like that hand fix, when you have so many shots and so many frames, I mean, yes, I guess someone could have fixed that, but the budget would have been impossible. And we were able to do this job with the hand fixes and some other beauty fixes for a budget that fit for the client. So this kind of opens up a whole new way of working and thinking about visual effects, and it's very cool. All right, bye.